Hello everybody! Today we are going to learn how to create a pseudo random numbers generator. So we are going to learn how to draw numbers from some kind of set. Okay, so how to do that? Well, we can create, for example, a variable that we sorted random number. So for example, integer number, and then I will assign here the result from the function that is called random. Then I will send this thing to the output. And let's see what that output is. It is 41. Okay, so let's compile it again. And as you can see, it's again 41. Let's compile it again. As you can see, it is 41. Wow, so great. It is really a random number, right? No, this thing is called pseudo-random. Remember, well, you know, what is the difference between the pseudo-random number and the random number? Imagine, right now I'm having a cube in my hand and I am throwing it. I might throw it with a bigger strength or lower strength, right? And every time that cube can meet different obstacles on the way, right? And then this is a random number. Totally random, because we don't know how exactly it will react with the environment around, okay? But the pseudo-random, so the pseudo-random number is going always, it is following some rules, okay? It is following rules because it is computer. Right now he can't throw cube and he will not meet the same obstacles, the random obstacles, and he doesn't have strength and other things like that. Okay, so he is following some rules always. Okay, so this is pseudo-randoms, and we can send the rules for that function here by using the function that is called the srand. Here in that here we can send the rule how that function will be working. Okay, this s is here, stands here for seat. Seats. This is just a set of values that we will get random values from, right? So I type here now 400, and you'll notice that this number is new now, right? And now I'll beat it again. As you can see, it is still the same, but this is not now the 41. So it means that for 41 here was different number. Now we change it to different number. Okay, let's see what will happen when we do something like that. As you can see, now we have 3 different numbers. So every time we have different number, and it's cool, but hey, every time I run the program, the number is the same. But when I change that thing here to something else, the numbers are being changed then, right? They are different. Then it's cool. So it means that we need something here that would change every time I execute the program. Tell me, what thing in our world is changing every second? Well, I just told you. It is time. Look, we can send to the output something, well, the result of the function that is called time. And here we can send as an argument null, because this function is taking as a parameter a pointer. I don't want to go into this detail of that function, but well, remember that this function is giving us as a result how many seconds are gone from 1090 or something like that. Well, never, it doesn't matter. The most important thing about that function is that the seconds every time will be here different. As you can see at the end we have 26, and now a few seconds later we have now here 32, right? So it is changing. This is the most important part in that thing. Now when I do it that way, you will notice that every time I run the program, that numbers all will be different. Great, cool. So now we know how to have always pseudo-random numbers. That's okay. So now let's create a function that will represent the lottery, okay? That function will be called lottery, and it will not return anything right now. And we will take two parameters here, two integers. The first one, let's specify the function here, will be how many numbers we will draw from, right? How many numbers we'll have in our set. So for example, 49. And as a second, we will have, well, maybe we can do it that way. For example, total balls. And here I will call it balls to draw or balls to allot. That are the same words, okay? And now we can create that function. It's like we'll use it later like that, and we'll send here, for example, 49 here 6, and I want to have send to the output after that, invoking of that function, 6 numbers from 49, and I want them to be all random, right? Pseudo-random way. And first thing, we should check what? We should check if the total balls is lower than balls to draw. Why? Well, because we can't do something like that, right? We can't get 1235 numbers from 49 and to make them all different, right? That can't happen. That's impossible. So we should check it, and then if the total balls is lower than balls to draw, we should just return. When I told you that we can't return anything, when here we are returning the void, because it is the empty. As you can see, we are returning nothing. We don't have anything after the return one. And this thing means that we are just leaving that function. So every instruction after that here won't be executed at all. Okay, so now we should also create a seed, right? So like that. Okay, and now we will create dynamically, because that thing here can be changed every second, array. So we will now create a pointer that we call balls, and we will assign here by using the new operator. So the new operator will return here the address for integer and the first address of integer array. That size will be balls to draw, right? So we'll store here the balls that will be drawn in that function, and I should delete that balls at the end of the function, right? Well, I should delete by saying deleting. I mean that I am releasing, I am freeing the memory that was dynamically reserved here, right? Remember about it. This is very important to do it here. Okay, so now we should just get that random number. So for int I equals 0 when I is lower than balls to draw, I plus plus. And now we should just assign to balls of I something, for example, random number. And now, well, we need numbers that are in range from 1 to 49. And soon I will tell you how to do that things. And let's send that thing to the output. So let's see the result. Let's just send it to the output right now. As you can see, we have now numbers. We have now 6 numbers that are random, but we need them, of course, to be from that range here. Okay, and here we will use something what is called the modulo operator. Right, we're coming back to the first lesson, and here, when I do something like that, look what will happen. As a result, we have now numbers from 0 to 48. Well, maybe let's train this thing a bit. Here, int number, random modulo, for example, 3, and now then send to the output that number. Let's do it that way. And also the seed. And let's send it to the output. As you can see, this thing was 1, now it's 2, and I will beat it again, and then it's 0, and then it is 1, and then it is 2, and again it will be 0, because that's how the modulo operator is working, right? It is giving us the reminder of that value here. If you don't remember how this operator works, please go back to the 6th lesson, I think, the arithmetic lesson, and you will see how that operator works. It's really important to understand it. So now, by doing something like it, we have the set of numbers like that. But I want to have 49 of that guys, right? So by doing something like that, oops, the comment, I will have numbers from 0 to 48, right? That way. If I want to have from 1 to 49, I should just add after it just 1, right? And then I will have numbers from 1 to 49, that way. Okay, so let's use the information that we've just seen here, and let's just do it that way here. As you and of course let's do it that way. And as you can see, now we have pseudo random numbers. Hey, but this guy is repeated here. They're the same. We can't do something like that. We want to have, well, the most time in the lottery, we want all numbers to be different. When I do something like that, 6 from 6, as you can see, well, of course, here is not 49, but we should change that guy here to total balls. As you can see, the numbers sometimes will be repeated, and we don't want situations like that. We want all numbers to be different. And now the true hard thing will start. Okay, so how to do that? We should just check all the numbers that have already been drawn, right? And if there is a ball like that in that set, it means that we should again repeat the drawing of numbers, right? Okay, so let's create an inner function here that will be invoking the instruction how many times? When g is lower than I, because I will represent how many balls we have already drawn, right? Then g++, and we can now check all balls one by one. Okay, so how to do that? We can do something like that. If balls of I equals balls of G, right? It means that we should just decrement the I, and because of that, we'll just repeat the drawing of number to that array. And we can break after that easily, because we know that if one guy is repeated, we don't need to check other balls, right? But we also should notice that the G might be here once equal to I, right? Because they might be equal here, we will check the equality of two the same balls. We will check something like, is balls of 0 equals to balls of 0? It might happen, something like that might happen, and of course this is true, and then this loop would start being the infinite loop, right? So we should check here by using the conjunction if the I is not equal in the same time to G. So if they are equal here, we won't just check if they check the equality of values in that arrays. Okay. Now, and otherwise we'll just send to the output, well, else if the G is equals I. So if we end that loop here, it means that the ball here that was drawn for sure wasn't repeated value, so we can send it to the output easy. For example, here, balls of I, right? And line. And now what will happen? As you can see, nothing. That's because this thing here needs also here something like I plus 1. Now all the values here will be always different. So I'm changing it to 49, and now I have 6 numbers from 49. They are all different. But why do I need the plus 1 here? Because I told you once that the condition in for loop is checked at the start, at the beginning, okay? So if it's checked at the beginning, we have to remember that the I at the beginning here was 0, and we are checking if 0 was lower than 0. And then the condition was just false, right? And that loop wasn't executed at all, and we couldn't send that thing here to the output, right? Okay. And now everything works fine. It's okay, right? Cool. Okay, that's all in the lesson. Thank you very much.